So sequences, nothing more than patterns, am I right? We establish what the pattern is, okay, and then we can go ahead and determine what the next couple of terms are going to be. I also like to think of sequences as dominoes. Set up the dominoes on the floor, and then each domino is going to have a particular value on it. Okay, so when it comes to sequences, there's really two parts to it. Number one, you're looking to find the value that happens to be on a particular domino, but you also need to be able to identify just what domino you're looking at. Is it domino number 8? Is it domino number 40? Etc. So that's where the superscripts are going to come into play here in just a little bit. But arithmetic sequences, we deal with this thing called the common difference. They want us to identify the common difference and then use it to find the next three terms. Common difference, you can go CD, that's good enough for me. Lowercase d is the variable that we're going to use in the formula here in a little bit. But what's our common difference here with this one? Yeah, -14, -9, -4, 1. It's always addition when you work with an arithmetic sequence. So +5. It could also be -5. If we were decreasing each time, we would just say -5. Therefore, the next three terms would be what? Go ahead. 11.
16.
And I consider that to be a pretty basic problem. That's where my Math 8 students start with.
That's the end of the lesson.
Almost. Almost. About a tenth of the way there. With these arithmetic sequences, we can have there is a formula that we can use to solve for something as opposed to just the fourth or the fifth term, because eventually they're going to ask you to find the 38th term or the 97th term and so forth. So we don't want to have to write out every value before it. We'd like to use that formula that gets us to that value right away. So for an arithmetic sequence, we're going to start out with a sub n is equal to a sub 1 plus n minus 1 times the common difference d. And again, there's really two formulas that we can use here. This is the first one. And notice we have this 1 right here. Therefore, this particular formula is used when we have the first term. Or maybe when we want to solve for the first term. But suppose we're given some pieces that don't include the first term. Maybe they give us the 7th and the 16th term. We need to be able to use something else that doesn't have the first one. So I'm just going to go ahead and replace that 1 with some generic m. Again, maybe it's the 7th term or the 16th term. Same idea, I'm going to replace that 1 with the m. There it is. So this is the one we're going to use when we're not given the first term or not solving for the first term. If I had to only give you one of these two, obviously I'd give you the second one. Because if you wanted to solve for the first one, you would just make your m 1. For example number 2, they want us to find the 15th term of that sequence. Now what some of you will do is you will go ahead and find the next term, and the next term, and the next term, and all the way down to you get to the 15th one, and you have arrived at your answer. And that's perfectly fine. Unless you're on the ACT where you're timed. You only have so much time to be able to solve these. So it's not very efficient. So let's go ahead and take a look at our formula that we're given. Although we're searching for the 15th term, we are given the very first term. So if we want to, we can use the first formula. A sub n is equal to a sub 1 plus n minus 1 times that common difference d. Now the first thing when you attack these problems is, can you identify the common difference? or do they give it to us? The answer is yes. Okay. What's our common difference here? We're increasing by how much each time? 11. Okay. We will get into the problem where they don't give you, or you cannot identify the common difference here in a little bit. But we know what the common difference is. That's good news for us. Okay, we want to solve for the 15th term. So I'm going to go ahead and let my n be 15. A sub 1. What's my n value again? Well, it's 15. And there's my minus 1. Common difference we said was what? 11. And what did we say a sub 1 was? Hmm? 4. Very good. The very first term, a sub 1, is 4. So let's take a moment and just look at this real quick. We have a lot of numbers up on the board. We filled in a lot of pieces. Again, understand with sequences, there's always two parts. It's what's the value that's on the domino, and then which domino are we looking at. This a sub 15 indicates that we're looking at the 15th term. Okay, a sub 1 indicates we're looking at the first domino. The first domino has a value of 4 on it. The third domino, a sub 3, has a value of 26 on it, and so forth. So these superscripts can get kind of confusing at first, but understand it's used to identify which term we're looking at. So now that we have everything plugged in, we can simplify this, correct? 4 plus 14 times 11. And the calculator would tell us it's what? 158. So again, we didn't have to write out the first 14 terms to figure out what the 15th one's going to be. We can simply go to our formula and we have it. Example number 3. They want us to find the very first term, a sub 1, of the arithmetic sequence given that a sub 7 is equal to 37 and a sub 6 is equal to 61. Interesting. So they've told you that domino number 7 has number 34 written on it. Domino number 16 has the number 61 written on it. We want to know what's the number that's going to be written on the very first domino. Make sense? So again, we start by asking the question, what's the common difference here? Well, we don't know, right? All we were given was the 7th and the 16th. So that's going to be step number 1. Find the common difference, or lowercase d. And how are we going to find it? Well, we have that formula. A sub n is equal to a sub m plus n minus m times the common difference d. Now they're giving us 2 of the dominoes with the values on them. So we're going to use that. Okay, use what's given to you. And when you do this, you can select your n to be 16, or you can let your n be 7. But I will give you a hint, you always want to use the bigger of the 2. So let's let n be 16. And I'll show you why here in a minute. Therefore, m is going to be your 7. What did we say our n value was again? 16. What was our m? 7. And this is the part where I told you let 16 be the bigger, be n, because a big number minus a small number will always give us a positive value, right? If you did small minus big, you would get a negative, which is okay, but now you're just dealing with negative numbers. What did we say a sub 16 was? 61. Very good. What was a sub 7? 34. And now don't we just have a bunch of numbers with a variable? A single variable, which means now we can solve for that common difference. So let's take a moment and just step back and look at this thing one more time. There were 1, 2, 3, 4, 5 places essentially where we could have plugged in a number. And we were only given 2 items. But again, it's the idea that not only do we have a value for each of those 2, but we also have a location for each of those 2. And it's with those 4 items we eventually were able to plug in 4 out of the 5 to solve for that 5th and final variable. Okay with that idea? Now let's go ahead and do our algebra. Subtract 34 to both sides. Divide by 9. Common difference is going to be 3. So what does that mean? Well, it means that the sequence that we're working with is increasing by 3 each time. Now we want to go ahead and solve for a sub 1. Now again, because we're dealing with a sub 1, if you want to, you can go back to that very first formula. A sub n is equal to a sub 1 plus n minus 1 times d. That's okay. So a sub n is equal to a sub 1 plus n minus 1 times d. Now for a sub n, you can use any of the 2 that's given to you. You can use a sub 7 or you can use the a sub 16. Me personally, I like smaller numbers, so I'm going to go with the a sub 7 and 34. So I'm going to let my n value be 7. A sub 1 is what we are eventually going to solve for. My n value, I said, was 7. And my common difference, we found that to be what? 3. What was a sub 7? What can I plug in here? 34. And now we can solve for a sub 1. Therefore, the very first domino is going to have the value of 16 written on it. Last one. So we're given that the 5th domino has the number negative 180 on it. We're given that the 12th domino has negative 138 written on it. We want to figure out what the 8th domino has written on it. Do we know what the common difference is? No, we do not. So that's going to be step number 1 again. I'm going to go a little bit quicker this time. A sub n, a sub m, n minus m. I used that one again because I'm not dealing with the first term anymore. I'm dealing with the 8th, the 5th, and the 12th. What do I want my n value to be? 5 or 12? 12. It would work out again if you used 5 here. Okay, it would work. You'd just get a negative value. That's okay. So let's let the m be 5. 12 minus 5, there's our positive value we were talking about, and there's our d that we'll solve for. What do I plug in for a sub 12? Negative 138. What do I plug in for a sub 5? Well, negative 180. Add 180 to both sides to get 42. Therefore, our common difference, we are increasing by 6 each time. So we found the common difference. Now we can go back and solve for whichever one we want to solve for. Now we want to take a look at a sub 8. Let's stick with the N and the M. And again, it doesn't matter to me which one you use. You could use the 5th or the 12th one. Let's use the 12th one just because it's a little bit smaller. We ultimately want to solve for 8, so that's why I'm going to let M be 8. You could, if you wanted to, you could have done this. You could have put your ace of 8 out there, and then you could have let your M value be ace of 5, or your M value be ace of 12. That's probably the way we should go. Okay, just simply because now it's set equal to ace of 8, but that's okay. Let's continue to go this way though. Ace of 12, ace of 8, 12, and 8. Common difference we said was 6. And ace of 12, the remaining piece we got to plug in is negative 138. We subtract 24 to both sides, we come up with the harder problems are going to be the ones where you have to solve for the common difference. Okay, if they don't give it to you, you have to do this first step over here to solve for that lowercase d. Then you go back and use your formula to solve for every one. Catching on? Notice for the first part up here when you get to your worksheet, your arithmetic, it's when you find the common difference, and there's your two formulas.